All right, this is Honors Algebra 2 Pre-Calc. We're doing 2.7 in Algebra 2, which is transformation of functions. So this is the second video in the series, and this will be a pretty long section in general because we're going to do a lot of examples. This is easier with hands-on practice. So what if there are multiple transformations? In the last video, we talked about a single slide up or down or left or right or flipping over an axis. What if there are multiple transformations? So you can kind of figure this out logically. Basically, what you're going to do is you're going to pretend that you're the x, and you're going to list the order that the transformations would happen to you, or to the x, except for one like weird thing, which is if they're inside the parent function, you're going to have to work in reverse. Remember how inside changes are backwards. So this isn't really an issue unless there are multiple changes inside the function. So for instance, you'll see two little written examples down here, right? You'll see down at the bottom that there's an A and a B. So in the example of A, if you were this x and you were to plug a number in as x, the first thing you do is add 2, which is the reason that left 2 is the first transformation. And then the second thing you do is the subtract 3. Now sure, the squared is actually the second thing you do, but remember that's part of the parent function. The parent function here would be an x squared. So the plus 2 is inside the parent function, and the minus 3 is outside the parent function. I would do plus 2 first, so left 2, and then outside the function, down 3. All right. But B is one of these tricky examples, and I'll be honest, I don't give you a whole lot of problems like B because, so what I mentioned in the first video is that most of the time learning this is useful because it allows you to shortcut to a visual of what a graph looks like without actually having to graph it. The honest answer is if there are enough changes on the inside, if it's really complicated, even I would just say, screw it, I'm graphing this thing, man, I'm not going to deal with it. So the advantage of this thing, the advantage of understanding what transformations happen and being able to mentally imagine the graph without doing the physical work of graphing it, those advantages lessen as the transformations get way too darn complicated. And as they get way too complicated, because of that, it's much, much easier to say, oh, you know what, man, I'm just not going to do that. I'm just going to graph it. So realistically, although we're going to walk through B and I'm going to show you how to do it, as someone who's done this skill for over 20 years, I don't use transformation knowledge to deal with a function that has a ton of stuff happening inside a square root or inside a parent function. It's just not worth it. But we're going to walk through it anyway and make sure you feel comfortable. I will, as we walk through examples, I'll make sure you know which ones you're likely to see and which ones are kind of outside the box from what you're going to see. All right, so in B, because of these multiple inside changes, notice that both the minus x and the plus 10 are inside the parent function, which would be that square root symbol. So those two are going to happen in reverse order. They're still clearly happening first, right? Because if you plugged a number into the x, the first thing that would happen would be a negative, and the second thing that would happen would be a plus 10. And this plus 4, which is outside of the parent function, is definitely later down the line, right? So the trick here is that when you're imagining it as transformations, even though you know that if you plugged in a number for x, the first thing that would happen is the negative, and the second thing would be the plus 10, you have to do those inside changes backwards because of the whole inside being backwards thing. So what's going to happen is you're actually going to go left 10 first and then flip over the y-axis, which is annoying because, again, the whole point of this is if it's not something that's simple to memorize, you probably wouldn't use this approach, which is why these are problems you don't see very much in a transformation of functions problem because, honestly, it's not a good use of the skill. So, and then lastly, I would move up 4. Okay, so we're going to walk through a whole bunch of examples. All right, so let's start with example 2. Now, example 2, the first function actually doesn't involve it doesn't involve multiple transformations. It only involves the one, right? But in the first function, we're going to go ahead and graph. So our parent function for both of these is an x cubed. I'm going to do my best job at graphing an x cubed with the understanding that I'm kind of terrible at graphing anyway, and then I'm even worse at graphing with this stupid pen. Okay. Cool, close enough. Okay, I'll do the same thing over here. So here's the 8 would be somewhere up here, right? And then, cool. Okay, so again, the understanding is that I graph like a child that can't write anything already, and then it's only worse when I have to use this pen. Okay, so now let's talk about this negative x cubed. So this negative on the outside is going to be a vertical flip, okay? So it's going to be essentially a reflection. That's not how you spell flip. It's going to be a reflection across the x-axis, okay? So visually what you're picturing is a vertical flip because it's on the outside of the function, so it's going to be vertical. So what's going to happen is you're going to use this x-axis. So I'm actually going to use yellow just to show you my axis that I'm flipping over. So that's my mirror, okay? So we're treating the x-axis as though it is a mirror. So a point that is on the x-axis would stay there, but a point that is 1 above the x-axis would flip to 1 below. A point that is 8 above, which is where this is, would flip way down here to 8 below, but I can't really draw that. A point that is 1 below the x-axis would flip up. A point that is 8 below the x-axis, sorry, my bad. Didn't mean to draw that. A point that is 8 below the x-axis would be somewhere way up here at 8 above the x-axis. So again, we all know I can't draw, but it would look something like that, okay? So now let's walk through an example that has multiple transformations. So there are two things happening here. There's a +1 on the inside and there's a -2 on the outside. So if I were the x and I plugged a number in, the first thing that would be happening would be this +1. Now that's the only inside change, so I don't have to worry about any weird backward stuff. So this is going to be left 1, right? Because the inside changes are always backwards. And then the second change is going to be that -2 on the outside, which is going to be up 2. Sorry, down 2. Come on, brain. Sorry, guys. Every once in a while you have a moment and your brain's just not swift. And my brain was not being particularly clever in that moment. Okay, so down 2. My bad. Sorry. Down 2. So if you need to do this in 2 different motions, that's fine. If you need to make a dot that takes each one of these and goes left 1, like this dot goes left 1, and this dot goes left 1, and this dot goes left 1. If you need that, that's fine, okay? If you don't, that's also fine. So as with everything we do, how much work you're going to need is going to depend a lot on you. So some people are going to go left 1 and then take each one of these dots and go down 2, right? Down 2, down 2, down 2 is somewhere in there. Okay. But a good number of you are actually just going to take each dot and go left 1, down 2. Left 1, like next dot, left 1, down 2. And that's also fine. Whichever one of those you are, it doesn't matter. You just have to be able to imagine what this function is going to look like, okay? So again, there's my really terrible version of a cubic, okay? So we're going to go ahead and do a P2 that you're going to try. All right, so same idea. One of these is just involving a flip, and the other one's going to be multiple transformations. So you can go ahead and pause me if you want. I'm going to graph the parent function, which is f of x equals the absolute value of x first on both graphs. So pause me if you want to do this by yourself. Well, those are almost graphs. Okay, cool. All right, so in this case, again, this is going to be one of those flip across the x-axis kind of situations, right? Because it's a vertical flip. It's outside the function, which means it's going to flip vertically like everything else. So here's my mirror, if that helps you. You don't have to draw the mirror. I just think it's a little bit easier for you to see it. So that's what I'm flipping across. So a dot that's already on the line stays in the line, but a dot that's 1 above the line becomes 1 below, 2 above the line would become 2 below, and so on. And the thing about an absolute value is that once you start to get a couple dots, it's pretty easy to see what's happening. And there's my g of x, okay? So for this second one, there are 2 transformations. Again, only one of them's happening on the inside, so there's nothing super weird about that. The first thing that's happening to the x is the -3. So that's going to be right 3. Right? And the second thing that's happening is this +1, which is going to be up 1. Cool. So I'm going to go ahead. If you feel like you can do both of those changes at once, that's great. If you feel like you need to do them separately, that's also fine. So each one of these dots is going to go right 3 and up 1. So honestly, some of you are only going to need that dot because you're going to say, oh, I get it, it's a V, that's the tip of the V, fine. If you need more dots than that, you could go right 3 up 1. You could get these couple dots, and that'll pretty much give you your V shape, and that's fine. How much work you show on something like this is mostly how much you need. I don't need to see a lot of work. I would ask that you tell me what's happening, which we did here, and then show it on the graph. All right. So now we're going to have 3 changes, right? So let's go ahead and E3. We're going to graph f of x, which is an x squared. So if you are able to graph x squared quickly, then that means you listened when I said you should memorize how to graph x squared, and that's awesome. If you need to actually plot the points, that's fine too. I'm mostly plotting the points because of how bad I am at drawing this on the thing. Okay, so there's my f of x. Now let's look at these changes, right? First thing that's happening if I plug a number into x is this -2, right? So the first change is right 2, right? That's the only change that happens inside the square. So there's none of these crazy, weird, backwards things that I have to worry about. The next thing that would happen to whatever number, because let's say you did 10 minus 2, you'd get an 8 squared. Then you do the negative. So the next thing that would happen would be to flip over the x-axis, right? A vertical flip because it's an outside change. And then the last thing that would happen would be this +3, which would be an up 3. So again, this is going to be one of those situations where some of you are going to be able to do this in one step and some of you are going to need to do some work on the way. Honestly, the end result looks the same to me. So if you need to take each dot and move it right 2, like if you need to make this little green U shape and say, okay, cool, in my brain, that's right 2, great. If you then need to flip it across this mirror of the x-axis, the point on the x-axis stays the same. Things 1 above the x-axis become 1 below. Things 4 above would become 4 below. Okay. And then your last move is to take each one of these things and move it up 3. Now, if you need these steps, that's totally fine. If instead you're like, you know, I'm pretty cool, I don't really need those steps, I can just jump to the answer, that's okay too. I'm not actually grading your ability to show the steps on the graph. I don't make you graph them in different colors. If you're someone who does each little graph on the way in the middle, like some people like to draw like a little dotted line graph here and a dotted line graph here, make sure at the end that you clearly label, oh hey, this is my g of x, right? Because most of us probably aren't using different colors. Like I have the advantage of doing this on a program right now, so I can do that. Some of you are people that have a disproportionate number of colored pencils or highlighters, and I praise you and wish I could be like you when I grow up. But a lot of us are just using a pen or a pencil and don't have the option for different colors. So make sure that your final answer is really clear, and then I don't care. Okay, so let's go ahead and do a P3. All right, same idea. You can pause me if you want. You're going to do an absolute value of x. I'm going to go ahead and get started and graph f as best as I can. It doesn't have to be perfect. I should be hitting those dots like 1, 1, 2, 2, etc., etc. All right, so there's my f. Now let's go ahead and walk through the changes again, right? So first change that's happening is that this thing's going to go right 1, right? The second thing that's happening is that this thing is going to flip over the x-axis, right? And the last thing that's happening would be this -4 on the outside, which is down 4. So if you need multiple steps to do this, some of you are honestly going to be able to like picture this in your head. Like you can actually, if we were in front of a class right now, you'd see me standing in front of you with my arms in a V shape, and I would intentionally step my whole body 1 step to the right with my arms staying in the same V shape, and then I would flip my arms upside down so that my hands are pointing down, and then I would stand up on my tippy toes to simulate, or sorry, bend my knees to simulate going down 4. I was picturing up 4. Again, I'm having a weird day with like not being able to handle directions. So point being, if I were in front of you in class, I'd actually show you with my body that I can picture what these things are doing, right? I have my arms in a V shape, just like this absolute value. I step 1 to the right, I flip my arms upside down so my hands are pointing down, and then I bend my knees to simulate moving down 4. And that's exactly what this is going to look like. So if you can picture that in your head, right? If you can picture moving 1 right, flipping upside down, and then moving down 4, some of you are probably able to get that this is the graph I'm going to skip to in the end, right? So move 1 right, flip over, so now it's an upside down V, which you have to kind of picture in your head, and then move down 4, well, that's going to look like, oh, I kind of missed that line, but you get the gist. That's going to look like this. And if you're able to do that in your head, it's not cheating, okay? Now, if you're not able to do that in your head, if you feel more comfortable saying, cool, I get it, I'm going to go right 1 and show that this is what it would look like, just a couple of those dots, right? And then I'm going to flip everything over and show that it would look like this, right? And then I'm going to take the last step of moving it down 4 and later. That's also great. Totally cool. Doesn't matter to me which one you feel better with, but you just need to make sure that you can do it. And again, this is what I mean when I say that what really matters is that you can picture the graph in your head. Oh, what I didn't do in the last one, but I can do now just to show you, is if you want to double check that you know how to graph stuff right, you could put in your original function, right? To get math, I go to, or to get absolute value, I go to math, I go over to number, I pick absolute value, and then I put x, right? And then here, I would have a negative in front. Make sure it's a negative, not a minus. Math, over to number, pick absolute value. Inside, I would have an x -1. Make sure that's a minus, not a negative. Close the absolute value, and then a -4. And then what you'll see when you graph is you'll see an image that looks like what we just graphed here, right? It really isn't worth taking the time to graph most of these, but it's good to know how to do it if you needed to. And this is an emulator that is worth using. It's not free, but you can get a trial that's free, and then there are lots of online graphing calculators that are free if you're doing homework at home. That doesn't help you on something like an AP test, but for right now, you know, it's helpful if you have one to practice with. All right, so let's do our next example. All right, so we're going to do E4. Now, E4 is the first one where I have multiple changes that are happening inside the function, and I'm going to have to pay attention to those stupid backwards rules that, as I pointed out, realistically, if I have multiple changes inside the function, I check my work on a calculator. I'm not lying to you. I'm saying, like, I just don't think it's worth it. I totally check my work on a calculator. Okay, that's a terrible job, but you get the gist. This is supposed to be done here at like 2, 8, but okay, I tried. And this should be like 2, 8, but I tried. Or 2, -8. You get me. 2, 8, -2, -8. All right, so let's walk through these changes. So the trick is that both of these are inside. There are 2 inside changes. When there are multiple inside changes, remember that means you do them in reverse order. So while I know that the first thing to happen to the x is the negative, and the second thing to happen to the x is the -3, I recognize that that means I do them in reverse order. So the second thing to happen is going to be the flip across the y-axis, right, because it's a horizontal flip. And the first thing to happen is going to be the right 3, right? So again, they go backwards. So if I have multiple inside changes, they go backwards. This is not particularly intuitive. Again, when I do ones like this, I definitely check them in the calculator. And I've been doing this for 20 years because I'm always like, oh, is that what happens? I forget. It's not super intuitive. And there is a logical reason that it works, but it's still not super intuitive. So here's my 3 dots, right? And if you need that, if you want to draw this little like part of a shape here just to see that that's where that squiggle is, it moves right 3, right? But again, really what's going to matter is these 3 dots because when they flip, that should give me enough to draw the curve. So now when I flip this across, right, remember that I'm treating this thing, actually let's use green for my mirror, right? So the y-axis is my mirror as much as I can manage to hit that, and my final answer is going to be in blue. So if I'm 2 units to the right of the y-axis, I'm going to move to 2 units to the left. If I'm 3 units to the right, I'll move to 3 units to the left, and it's 4 units to the right, it's going to move to 4 units to the left. And there is your x cubed. Close enough. You get the gist. Okay, so now let's put that in the calculator because, again, these are awkward and it's worth checking. So when we put this in the calculator, right, I'm going to make sure that this is an x. I use √3. I know that there's a cubed in the math section. I just don't care. In parentheses, I'm going to have a negative. Make sure it's a negative, not minus. X minus 3. Close the parentheses. √3. All right, and we're going to go ahead and graph it. And that confirms that we have the graph that we want to have, right? And you can see that. Oh, if you want, if it's easier for you to see which one's the new graph, go to the second graph and turn on the thicker line. Then it'll be clear that your F graph is the thin line and your G graph is the thicker line. But that's exactly what it looks like. So we're going to go ahead and try P4. You can try it without me if you want. I'm going to graph my square root of x first. And again, this is one that has 2 inside changes, right? So pause me if you want to try it on your own. Remember that inside changes, if there are multiple, happen in reverse. So the first thing that happens is the green thing, which means that's going to be the second change. So the second change is going to be to flip across the y-axis. And the second action in here, because these are both inside changes, is going to be the left 2. So I'm actually going to go in that reverse order. So the first thing I'm going to do is do left 2, which is going to give me dots that look like this. Then I'm going to treat the y-axis like it's a mirror, right? So there's my mirror in green, right? So mirror. And in blue, I'll put my final graph. So if I'm 2 units to the left of the mirror, I'm going to land 2 units to the right. If I'm 1 unit to the left, it lands 1 unit to the right. And if it's 2 units to the right, it lands 2 units to the left. And there should be my square root graph. So then we can check that, right? We can check that again by plugging our stuff in our calculator. So we're going to do second root x. And then down here, we'll do second root negative x plus 2, and we don't need the cube stuff. All right, that looks right, and we'll graph it, and sure enough, that's our graph. It matches what we had, right? The black line for us is the narrow line, and the blue line we drew is the thick line, okay? So that's how it works. All right,